There's still a few more people trickling in, but let's get started. First of all, thank you everybody for joining us today. I'm Joe Mossbrook with Identify Sensors Biologics. We have Dr. Tommy Soers, PhD from Purdue University. Tommy is the Assistant Director of Purdue Institute of Inflammation, Immunology, and Infectious Diseases. We have Dr. Gregory Hummer, co-founder and CEO of Identify Sensors Biologics. Gentlemen, thank you both for joining us today. This is a great conversation that we're having because there's been a lot of stuff. There's been a lot of information in the news recently about where we go from here as far as the pandemic and what it's going to take to sort of get us closer to normalcy. But before we do that, I know we've got some investors on the call. Dr. Hummer, do you want to talk a little bit about the company and the progress of the test?
Sure. Thanks, Joe. And thank everyone for attending. We're making very good progress on the test. The test, as you know, is an accurate test. It's not an RT-PCR test, and it's not an antigen test. It's somewhere in the between. And we've got good reports out of Purdue informing the electrodes and also the reader. We should have a prototype of the reader by the end of this month. Moving on to the electrode and functionalizing the electrode for easy manufacture and rapid scale up. So that's all good news. The sensitivity and specificity is in the range of RT-PCR, and we're working on making it a little bit more sensitive. Tommy, do you have anything to add on that?
No, I have to say that I agree with everything you've said so far. It's really been a great journey, and we are excited and about the results that we're seeing in the lab so far with the sensors, and happy to start bringing in the reader prototype as well. And start making progress there towards the EUA application.
Great. So there's been a lot of information in the news just in the last 48 hours about where we go next. Clearly, we're not on a path to herd immunity anytime soon. The vaccines are rolling out, but not rolling out to the entire population. There's still a large segment of the population. I've seen statistics as high as 35% or more of people who just won't take them for a number of different reasons. So that leaves us sort of in a no man's land a little bit. Dr. Hummer, can you talk a little bit about what this pathway looks like to people getting back to work and traveling again and some level of normalcy?
Well, the only thing I can say for sure is that someday we will get back to normal. When and how remains to be sorted out. Just yesterday in the Bloomberg reported an article by Christopher Murray and a Peter Piot about that this pandemic is going to be here for a long time. And I think they're right. Their logic is good. What we're dealing with right now is a virus that is fairly common, but it's mutating very rapidly. And now we have variants in Brittany, France, and South Africa that are seemingly more infectious. And that's a bad thing. That makes the virus able to infect more people more rapidly. You get an exponential infection rate instead of a linear one, which means that the virus can use a host to replicate itself and thus mutate even faster. So I think we're going to find that vaccines aren't the only answer. And in fact, the way things are going with vaccines right now, it's probably, if we had to rely on just a vaccine alone to get herd immunity, that's years off. And that's if they continue to work. Now, some of the variants now are not susceptible to the new vaccines. So that could be a problem in and of itself. So I think going forward, a test that is accurate as RT-PCR, but doesn't logistically sop up enzymes, reagents, machines, and people, and is very costly, that's not the solution. I was just
No, I-
told that. I was just told the other day that Georgetown University, I think one of the people is on today, I see, wants to do a RT-PCR test twice a week on students, costing about $15,000 a year per student, which is absolutely ludicrous.
Well,
Sorry. Go
and
ahead.
Greg, I don't mean to interrupt, and I just wanna uh, follow on what you were saying, and even go a little bit further, because whether this vaccine regimen and how we're laying it out and how many people are getting vaccinated, that's another constraint that we're really worried about in terms of getting this herd immunity that you're speaking of. But what I want the people on the call today to remember is that it's COVID today, COVID this past year, but it was SARS and it was MERS and it was avian flu, and it's going to be some swine flu something that is coming tomorrow. And the flexibility in our tests that will allow us to pivot quite rapidly to create new solutions, to identify new solutions, that's obviously in the future. But right now, the flexibility of our tests is such that it should be able to detect any of the variants that are circulating right now. It won't tell you exactly which one you have, but at least it's flexible enough to detect any of the ones that are circulating, and it will give you that yes or no answer that you need immediately to know at home, or the place where you're working, or the place where you're seeking that medical attention. You need to know right there what it is that you have. And whether it's COVID today, influenza tomorrow, and all the other pathogens that we have on our list to start developing sensors for, that is exactly where the FDA wants us to be. And if you recall, that conversation that we just had with the FDA at Purdue was exactly that. They're looking to disrupt the way diagnostic testing is done currently. And the way that the RT-PCR and these rapid antigen tests have shown that they are not really well made for dealing with a pandemic of this size. They're not really designed for diagnostics at that scale. We need to come with solutions like ours that give you at the palm of your hands the results within minutes, and just from a saliva sample.
Yeah.
Dr. Soares, what, in your mind, and based on the research in your department, what does COVID-19 look like in 2022?
Well, it's hard to say. I think, and as Dr. Hammer was mentioning, there are so many variants that are circulating right now, and the danger is that we have variants of variants. The ones that are circulating in Brazil now are being detected as variants of variants. So these have mutated ones and then have gone around the population once again and picked up more mutations. So the danger there, as Dr. Hammer presented, is that perhaps these vaccines are not going to be as efficient as time progresses, and we're going to need to keep making vaccines year after year, perhaps like we do with the influenza vaccines.
I believe that, a war is never won on a direct frontal assault. The assault on this virus will take many types and places, and of course, direct testing of an individual in your home, like Tommy said, with a device in the palm of your hand, will let you know if you have the virus, even if you're asymptomatic, because it's a molecular gene test. And then that works because it's a digital output. We can take that signal and put it to the cloud, run it through an algorithm and determine the answer, yes or no. And then we have automatic reporting to state health labs and therefore into the CDC. So this is going to be important in the next pandemic, which who knows when, but according to Tommy, we've faced this before, and according to Christopher Murray up at the University of Washington, we're bound to face this again. And there was a recent study done by a group, the name eludes me right now, where they took the bats from a particular area in China, in the Wuhan area, and they found that there was 23 different versions of this virus. And they extrapolated that to the rest of the world, and the numbers of variants could be enormous. So we're going to face an enemy that's has a lot of different tactics, a lot of different angles. But the one thing that we know for sure is if you have a test that can detect that RNA accurately, quickly, without a lot of resources, then you'll know if you have it, and you can not go to work, you not fly on an airplane, or not go on a cruise ship. And the more people know that if they're harboring the virus and they stay away, that means the virus chain will be broken. And that too will be an effective adjunct to a vaccine.
Joe, we've seen this year, because of the pandemic and the shutdown, we've seen this year a decrease in the amount of flu that has circulated around the public. And it's because we've been in shutdown, we've been wearing masks. People have been hopefully more conscientious of how they go around in public and dealing with this pandemic. And we've seen these measures take in also a positive effect for influenza, for example. But wouldn't you like to know? Wouldn't you like to know if you got an itchy, scratchy throat and you woke up one morning and you said, oh my gosh, do I have COVID? Do I have influenza? And the best we can do right now is, yeah, sure, wait a couple days. I'll let you know with my tests, our RT-PCR tests, exactly what you have. But you're going to have to wait a couple of days. And we're trying to really come up with a solution that is going to change that completely. And I know Greg spoke about the solutions for tracking and helping us deal with the pandemic, but for the users of our test, for them to have that power of knowing within minutes that what they have or what their child has, because if we're able to detect influenza before the child goes to school, can you imagine the types of levels of flu that are going to be circulating, or COVID, or as Greg said, the next coming pandemic? And the other thing to realize is that this particular platform technology is adjustable, is flexible, is today COVID, it's MRSA tomorrow, it's Hep C, it's EV68, and some of the other viruses and pathogens that are circulating that maybe they don't get the press that COVID gets because they're not killing the millions of people that are being killed by COVID, but that are significant, and they do derail our economy every day.
Yeah, I think
That's
there's
a good,
there's a pretty good understanding that testing is needed, and there's also some public misconceptions about the current test. There's a lot of different tests on the market now. Dr. Hummer, can you kind of go over the three basic ones, PCR, antigen, and antibody tests, and talk about the pros and cons of those?
sure. Well, the RT-PCR test is a test that's been around for over 50 years. It's a very good test. It was never meant to be a diagnostic test, more of a laboratory test. And it consumes a lot of resources, and those resources have to be in good condition, the enzymes, the machine, the people who run it. It's a very good test. It's very accurate, and it uses a process called amplification. Our test does not use amplification. The RT-PCR actually finds a specific gene sequence and then amplifies it many, many times. The usual is about 35 times, but it can go up to 45, and a lot of tests are going up to 45 right now, cycles. That's something around 10 to the 10th power or 10 to the 11th number of genes before they can get the test and have an accurate result. We use untreated saliva straight from your mouth, and we were able to detect the RNA N gene, and that is a crucial distinction. And that means that we're able to be very efficient, be very fluid in the way this test is administered. And the shelf life also will be amazing. We're planning on over 2 years, probably or more, of shelf life. And again, the reader can be reused for other tests, as Tommy talked about in the platform. So the antigen test, that's the second type of test. The antigen test for surface proteins, and those could be part of the S spike protein or other proteins, but most of those are geared towards the spike protein. And as the virus that mutates, there will be changes in that spike protein, and that's where we're seeing most of the changes now. And as that spike protein moves away from what the current antigen tests are, you're going to start to see a lot of false negative tests. Right now, you can have false positives too, because some of those proteins are similar to coronaviruses, 1, 2, 3, 4, 5, and 6. This is the 7th coronavirus. So they're not as accurate. They're very inexpensive. And I've got dozens of examples of people that have had an antigen test that was positive, falsely positive, had to change their plans, their travel plans, their business plans. Mike DeWine, the governor of Ohio, was supposed to meet with President Trump and had a fast antigen test and was positive. Later went back to Ohio State Medical, the university there, and had an RT-PCR test, which was negative. So we're trying for an accurate test. We're not an antigen test. We're not an RT-PCR, but we are a molecular gene test, and we do it differently. And then the antibody, when you have an infection, your body produces antibodies, IgM, IgG antibodies. These antibodies are around for a while. They can be detected in the blood, in the serum. And an antibody test really is not an effective tool for a pandemic because it's after the fact. We're focusing on during the process of keeping people from spreading this. And by keeping people from spreading it, we can effectively help break the chain, just as a vaccine would do. Unfortunately, Tommy went over the problems with the vaccines that they're going to have. And so we think this is a valid, viable way. We're working very diligently on this and to make this easily manufactured, all within the United States. And we're in that phase right now where we're optimizing this for manufacture, and Purdue University is really doing a good job for that. They have a whole materials management engineering department, and we're taking advantage of that. Tommy?
No, absolutely. I have the pleasure of representing Purdue, and I say that with pleasure because we represent some of the best expertise and the resources, the facilities that we have in place for some of these world experts in materials that are really exquisite and are being made with utmost care to make sure that the sensitivity and selectivity of these electrodes is there. So let me tell you a little bit, just if I can, Joe, I hope you don't mind, but I just wanted to let everybody know here that the people that we're working with at Purdue, Dr. Leah Stanshu and Dr. Rahim Rahimi, they work in what's called the Burke Nanotechnology Center. And in this center, essentially, the whole building is dedicated to maintain a clean room, essentially the size of a football field. And this clean room environment is where we are making these electrodes, and we're printing these electrodes using nanotechnology based equipment and instrumentation, but also with the engineers, the research scientists that know how to use the equipment, that know how to use the facilities to help us start producing electrodes that and these biosensors that are helping us to produce a product that can be manufactured. So we have scale up capabilities at Purdue that will allow us to then pass on what electrodes and what sensors we develop at Purdue much quicker to a manufacturer so that we can start developing the products.
Uh, Dr. Hummer, as we sort of move forward and try to do things like get on airplanes, go to sporting events, hold weddings, all the sort of things we remember a year or so ago, what is that going to look like?
Well, I believe what that's going to end up looking like is an individual test like us. Like, let's say you're you're going on a cruise, and everybody that's gone on a cruise, usually on these boats, there's a waiting area. Everybody collects there. Uh, you would be able to test every single person that's going on that boat within a 5-minute period for each person. And the way we've constructed and engineered this, you can literally have thousands of tests happening simultaneously through Bluetooth at the same time. So you could literally test everybody before they got on that ship to see, even if they were asymptomatic, if they were carrying a virus. You can also test the people on the ship, the crew. So same could go for airplanes or Live Nation, concerts, athletic events. So I think that's the way that we're going to get safely open. I would like to say that everybody could get a vaccine and that would do the trick, but I think that would be oversimplification. We need a strategy that involves rapid, accurate testing that's ubiquitous in the areas of, employment, travel, and school. And those are the main areas that I believe that we need to get back to normal as soon as possible. And our test will allow that.
That's great. I want to be respectful of everyone's time and try to keep this to half an hour. Um, uh, Dr. Soers, regarding this technology, and from my understanding, this is all new technology that's outside the current PCR chemical antigen model. And clearly this, and I know Purdue University started working on this before the pandemic, and the pandemic accelerated the need to do so for COVID-19. But looking beyond the COVID-19 test, when that rolls out, what do you see? How do you see this test affecting medical diagnostics going forward beyond that?
Well, I really think it's going to change the way that first the FDA and regulatory bodies who are really watching out for our safety, they're going to really be convinced that this is the way to go for at-home testing. And that Greg always paints it the best. What we really want to do is bring that laboratory, diagnostics laboratory to the medicine cabinet for people at their home. Now, we start today with COVID. We have access to start working very quickly on influenza. As I said, EV68 and other enteroviruses. I mean, I work very closely with the people at Purdue that are some of the world experts on what are called flaviviruses, like dengue and Zika virus, for example. I work with Dr. Richard Kuhn, who was the first to decipher the structure of Zika virus, the structure of dengue virus, for example. And so these are some of the lower hanging fruits that we have available to start working really quickly on and start retooling what we did for COVID, immediately pivoting and doing something quickly for some of these other pathogens as well.
For all of you potential investors out there, this is a platform not only for viruses, but for also other pathogens like MRSA and E. coli serotypes that affect the food supply chain. In fact, we originally got started in this by designing these sensors for the food supply chain,
Correct.
particularly for fruits and vegetables. So we will be taking this technology and also applying it to the food supply chain worldwide and testing for E. coli serotypes, Shigella, Salmonella, and things like that, Listeria, that affect the supply chain today. And we know that just in the United States alone, the people are getting sicker at a more rapid rate, more and more from the food supply chain, and the food supply chain now spreads out throughout the world. So we're going to be using this technology to help the food supply chain in the world stay safe. In fact, 2 years ago, when there was a romaine lettuce recall, they recalled all the romaine lettuce in the United States because of an E. coli serotype. That farmer, I won't mention his name, but in the Salinas Valley, is now an investor in this company because he was originally contacted. We didn't know he was the farm that produced the lettuce, but he said, if I would have had this, I could have saved a lot of problems. And it's true. With these types of tests, not only will the farmer be able to test before it ships, the middleman will test, and they'll test at the loading dock of the Walmarts or the grocery stores of the world. And then even at home, you'll be able to test. So we aim to use this technology in various different ways, not only just for like infections like MRSA, which is, by the way, a $20 billion a year problem in hospitals, but surgical wounds and surfaces. We'll be able to detect MRSA on surfaces and surgical wounds within 5 minutes or less. So that's a very, very broad market that we're going to be appealing to. And so as potential investors, I think that's very appealing.
Yeah, Dr. Hummer, let me just pull that thread a little bit. What does the current, I know MRSA plagues hospitals all over the world. What does the current MRSA testing look like right now, and how will this change?
Well, it's not rapid. It's not flexible. Most MRSA infections are probably in older people that have a joint replacement, knee, hip, or something like that. And as you know, when you get a MRSA infection in a Medicare patient, Medicare doesn't pay for the infection because they figure that's on the hospital. They screwed up. So this is a big problem. And most of the time you're taking a culture to culture this bacteria, which can take days. So we're going to develop, and we're working on shortly, a surface test, an environmental test, and also a biological test for when a surgeon's, doing an operative procedure to see if there's MRSA in and around the wound before you start, or in and around the operating theater, or even in the wound before you close up. So this is a very flexible technology. Just think of it like this, folks. If it has RNA or DNA, we're going to be able to find it.
That's great. So I do want to wrap up. We want to keep it to 30 minutes. Tommy, do you have any final thoughts?
Yeah, I mean, I want to bring it back to check for COVID. This particular test, I know we've been all over the place talking about some of the other opportunities that will come back for this particular technology, but I want to address something. I do a lot of work in my field in global health, And I know that we have a test that is of great need, not only to us here in the United States, but to people around the world. Once we're able to get something into their hands, I think we're going to be able to start making really good progress on a global scale as well as a national scale. So thank you for this opportunity to speak in today's webinar, and thank you, Dr. Hummer and Joe.
Yeah, Tommy, thank you very much. Dr. Hummer, thank you. Thank you everyone for joining us. Just a quick note, we will be sending a recording of this out to our larger email list, and we're going to, as we, I think, get closer toward FDA emergency use authorization approval, we're going to start having more of these conversations to keep everyone apprised of our progress going forward. If anyone has any questions for anybody at all, please reach out. I think our contact information is on the website, and you'll hear more from us very soon. Thanks again for joining us.
Joe, I just wanted to say
Oh, sorry. Yeah, go ahead, Greg.
one last thing here, and that is as we're preparing for EUA and hoping to get EUA as soon as we can, that's not going to stop us from manufacturing and selling to countries outside the United States. We've already had inquiries from several different countries and several large organizations that are aware of our tests. So for those investors out there, think about manufacturing and early sales outside the United States, but we're hoping to get EUA as soon as we possibly can.
Dr. Hummer, doesn't that also include governors of American states?
That's true. Governors of the states, the 50 states, can choose to use a test which is not EUA approved, depending on their own ideas of what the test could do and what the validation data shows. So that's also a possibility too.
Great. Everyone, thank you so much. We will see you soon.
Thank you very much, everyone.
Thank you.
Thank
Bye-bye.
you.
Get out there and invest.